All right, let's talk about some special cases in factoring. On this first one right here, your book and your teacher is probably going to make a really big deal about it. But honestly, if you can do the factoring we've already been doing, this special case doesn't even matter to you. You'll learn this formula: a squared plus 2ab plus b squared equals a plus b quantity squared. By the way, you can also have a minus in there and the same equation but with a minus sign. Here's the big thing. The third term has to be positive for this formula to work. And what this is basically saying is that if what's in front of the x and what's out here in the third, if they're square roots, okay, and then you could take the square root of that and double it to get the middle, you get this special situation. But watch, I'm not even going to use the formula and watch what happens. What multiplies, well, third term positive, signs are the same. Take the sign of the middle number, which is going to be plus and plus. Okay, well, what's the square root of 36? Well, forget that. What multiplies in the 36 but adds the 12? And you may find already the answer is 6 and 6. You've been doing that already. Well, if I have x plus 6 times x plus 6, I can just write it like this: x plus 6 quantity squared. That's all this is showing you. You already know how to do this. Just make sure that if it comes out as the same parenthesis, you write it like that. It also works with a minus sign. I'll just do it real quick. Watch, I'll put a minus sign right there. What multiplies in the third? Okay, sorry. Let me start over. Third term positive. Signs are the same. Take the sign of the middle number. Okay. What multiplies the 36 and adds the 12? Well, the answer is going to be 6 and 6. So my answer here is going to be minus 6. So you can see the middle term doesn't really matter. However, if you're going to take a square root of something, you can't do that as a negative number. Okay, so it only works if the third number is going to be positive. Okay, so there's that. So that one, you didn't really learn anything new. I'm just showing you how this formula works, and you can just do it our normal way, how we've been doing it, and you're going to come up with an answer. There is one that is kind of special, though, and so I want to show you that, and that's called the difference of two squares. So let's get that one up here. Okay, ignore this x squared minus 9 for right now. You're also going to learn a special case, which we call the difference of squares. A squared minus b squared equals a plus b times a minus b. Now, let me just show you the y, and then we'll do a lot of shortcuts, okay? So it's a nice shortcut, so you don't have to do it the long way. I'm going to do one the long way. I can look at this, and you look at this and go, well, boy, this looks a lot different than the ones we've been doing because there's no x value. Well, if there's no x value, isn't it really just this? X squared, I'll just write plus 0x minus 9, okay? Because that's a 0x, right? Let's go ahead and just factor like we normally been factoring, okay? Third term is negative, so my signs are going to be different. Signs are going to be different, okay? And what multiplies to 9 but subtracts 0? Well, the answer is 3 and 3. And that's how we get our a plus b, a minus b from the formula. This only works if what's on the left-hand side is a perfect square, what's on the right hand is a perfect square, and it has to be minus. This does not work with a plus. Okay, if you saw a plus, not factorable, you're done. Okay, so now what I'm going to do is I'm going to put a bunch of these on the board, and we're just going to run through them, and you'll see that these are really pretty quick and easy. Okay, so let me just get a bunch on the board. Okay, I threw a couple tricky ones up here also, so let's just watch this. So when you see a perfect square minus a perfect square, what you're going to do is you're just going to write two parentheses. You're going to do a plus and a minus. You're going to put the square root of him there, and you're going to put the square root of him there. And it's really that simple. Okay, so that's how we're going to factor perfect squares. Okay, this one's a little trickier. In fact, I even made it trickier than trickier, and I'll show you why. Okay, so don't get freaked out on this one. Y to the fourth is still a perfect square. If you have an even exponent, what you're going to learn is that that's really just y squared times y squared. Okay, so, and that's 81. So really this becomes, I put a y squared and a y squared, and the 81 becomes a 9 and a 9, and the signs are plus and minus. So you can do that. You just take that one and you cut it in half. Done. Except I'm not. Why? Can you see why I'm not done? What am I left with here? Y squared minus 9. Look at that. That's, again, perfect square minus a perfect square. I can't do anything with y squared plus 9. He stays the same. So I'm just going to copy him down. Okay, now look at my answer. Now I've got to break him down to a y plus 3, and he becomes a y minus 3, and now I'm done. So sometimes when you factor, you're going to be left with something that you can factor after you factor. So that's a little crazy. Now look at this one. I put something in front of the x squared. Who would do such a thing? Well, this works as long as the thing in front of the x squared is still a perfect square, and 25 is. So remember, just using our little formula that we're using, square root this guy. What's 25x squared? That's going to be just a 25x. Oh, sorry. That's a 5x, my fault. Okay, 5x and 5x. The 9 becomes a 3 and a 3, and the signs, of course, are different, plus, minus. So it's okay to have a coefficient in front of the x squared as long as it's also a perfect square. Okay, so we have some special cases that are in the worksheets. Work on those, and I'll see you there while I work those out. And I think you'll find these kind of easy, and maybe, God forbid, it might even be fun. So I'll see you there.